Hello and welcome to CNC Beginner's Guide. My name is Stephen Thompson, and in this tutorial we're going to be going over how to create the second setup for Project 2. Now, if you remember in Project 1, we only had a single setup, and effectively what that means is we only machined our stock material, or our model, out from one side. Sometimes that's okay, sometimes that's all you need, but a lot of times parts have features on multiple sides. And if you're working with the constraints of a 3-axis machine, or sometimes even the constraints of a 5-axis machine, you're going to need to create multiple setups so that you can machine features on multiple sides of your object. Now, it's not always the same how you set it up. It's not always straightforward, but we're going to kind of do a first pass here on this Project 2. We're going to flip our part over. It's known as flip machining, and we're going to remove all of the extra stock material from the back of our part. So yeah, why don't we get going? Okay, so at the end of setup 1 for Project 2, we created all the toolpaths to machine the top. And if we take a look at this, if I simulate this, we can see, if we go to the very end of the simulation, kind of where we're at. So we have the part here, all these features are machined, we have a hole that goes all the way through, but we still have this stock material on the underside, on the bottom side of this model. And we want to remove all of that material and kind of go all the way down to the bottom of the model. There's no extra features on the bottom of this part that we need to align with the features on the top. So we're just going to remove the material, and that's it. In the next project, we're going to machine features on both sides, and that's going to require a third setup, actually. Okay, so I'm going to exit the simulation, and let's go ahead and create our second setup. So I'm just going to go to Setup and New Setup. We see Setup 2 appears down here, and this is our Setup dialog box. So machine, we're going to leave that one empty. Operation type is milling. Orientation, so if we take a look at how this was oriented before, like this, with positive X pointed to the right here, positive Y away from us, and positive Z up, what we want to do is basically flip it over. So we're going to flip it away from us. So I'm going to flip it away from me. And now I have a new up direction, right? So I'm going to say orientation, change it to Z-axis plane and X-axis. And I'm going to click the top surface here, which was actually the bottom surface, which is now the top surface of this model. And I see Z points straight up. And so that is the new orientation. And the X is pointed to the right here, and Y is pointed away from us. Because this object is symmetric across the YZ plane, I guess it is, it doesn't matter if it's oriented like this or oriented like this. It's going to be the same. But if your part is not symmetric in that direction, then the way that you flip it and the orientation of the axis here is really going to make a difference. You may, if you do it incorrectly, you may get features on one side that should be on the other side. Okay, but for now that looks it looks good, and X is asking us to define X-axis. It's already in the right direction, so we can leave that. You could click align, and it would just kind of define it more clearly. And then the next thing for origin, click on box point next to stock point, and then you click where here on the stock you want to set your work coordinate system origin. And it really depends on what your machine's capable of doing. If you have like a probe on your machine that can find the center, or if you have an edge finder that can find the edge, or maybe your probe can only find the edge. It really depends. I know that the machine I'm going to use can find the center top of my model, so I will put it there. And for model, we click on body. It should already be selected there. If it's not, make sure you specify that one body as the model. Fixture, I'm going to leave that kind of empty there. That's if you have a vise or other work holding that you want to define. But we don't have any work holding in our model here. Okay, in the stock tab, for mode, this is nice, from preceding setup, which is the default when you create multiple setups. So that means that the position of the model inside of this stock material and the geometry of the stock material is going to be the same as it was in setup 1, which is exactly what we want. So we'll leave that there. For post process, program name number, I'm going to call this 2002, 2002, which is project 2, setup 2. And I'm going to write that, project 2, setup 2, and then your name. Okay, WCS offset, I'm going to leave that as 0. It depends on kind of how your machine expects it to come in. It's going to be either 0 is going to default to G54, or you could write 54 in there for G54. And that's the most common. Anything else is more and a more advanced thing. Okay, go ahead and click OK. And we have our second setup. Right. Okay, so what do? We want to remove this material from the top. Well, I'm going to simulate setup 1 again. Right click setup 1 and simulate. And go to the end. And I can see here we are left with a little bit of material hanging over the side of this part, and then material from the top. Now, it might seem like it would be a good idea to come in with a face mill and machine this down from the top with a face mill. And for a little bit, that would be okay. But we actually have a really dangerous situation here. It does not seem very dangerous at all, but it is quite dangerous. And that is what it was going on right here. So this is known as an overhang. An overhang is any unsupported material. And the rule with overhangs is you do not machine on top of overhangs. It could be cantilevered like this, or it could be bridged between two supporting surfaces. In any case, you cannot machine on top of an overhang, because what will happen is basically the material itself will bend away or deflect away from the tool, and then it'll kind of go back into the tool, and it'll start to vibrate. And it'll make a lot of crazy noise, and it'll basically be colliding with your tool. So you get a terrible surface finish, first of all. And then it gets really dangerous when this thing can happen where the material kind of forces itself into the tool because it's vibrating, and it over engages with the tool, and it's so thin that the tool can actually rip it a little bit. And it gets caught up in the tool, and the tool can throw it out of the vise and against the side of the machine, or if your machine doesn't have an enclosure, it can throw it across the room. Very dangerous projectile type situation. Okay. So what do? Well, the thing we have to do with overhangs is we can either support them. If it's like a bridge between 2 points, we can support from underneath if we're not going to be machining underneath it. But we want to remove all this material, so we're actually going to come in from the side and do a lateral cut with an end mill, just to remove all this overhang material, and then we'll go in and we'll face the material off with the face mill. Okay. So one thing that's important to note is that now that we have 2 setups, we have what's known as the active setup. So if you see the little dot next to setup, if you click on that dot, it'll activate that setup. What that means is that it's going to show that stock with that work coordinate system. It's also going to, if you add a new toolpath, it'll add it into the active setup. So since we're doing setup 2, we want to activate setup 2. Go ahead and click on the button next to setup 2, and we can see that the orientation of the work coordinate system is correct. And yep, setup 2 is the active setup. Great. So first thing we're going to do is we're going to do a adaptive clearing from around the outside. So I'm going to do 2D adaptive clearing. For tool, click select, and we can go to our project tool document right here, and we can find a tool we've used so far, like a larger end mill, half-inch end mill. Looks good. And click select. Okay, and what we want it to do is to actually machine everything on the outside of this contour. So for geometry, I'm going to select that what is now the top outer contour. We can see it shades everything on the outside of that. It's going to remove all the material on the outside. For heights, we can leave that, and for passes, make sure you check stock to leave. And what that will do is it will leave radial stock and axial stock, so that the tool doesn't get too close to the model. It'll leave a little tiny little overhang, but it's not going to be enough to be dangerous. So we'll leave that as is. Go ahead and click OK. And actually, let's go back to that adaptive, and I'm going to edit it. And let's see. One thing we didn't do was in the passes tab, we didn't check the optimal load. So the optimal load is the amount of tool engagement during adaptive toolpaths. And what is a good optimal load? I'm looking in the book right now, CNC Beginner's Guide. And I have a table at the very end on page 274. And it says a good optimal load for a 1/2 inch diameter tool in aluminum is 0.1348. So I'm going to write that. 0.1348. This is a number that is kind of determined experimentally on a machine, and I know that this works for the machine that I'm using, but it might be too much for the machine that you're using. It depends on the power of the machine, and a few other things, the horsepower of the spindle, stuff like that. Okay, so that looks good. Go ahead and click OK. And let's take a look. I'm going to right click on setups, both setups, and simulate. And that way it'll show everything from the first setup. I'm just going to click on the adaptive, which is the last one here, and I'm going to click play. I'm going to take a look at this from the side. I want to be sure of something. I want to make sure that we're not machining. Yeah, okay. So one thing I was kind of thinking of and was maybe a little bit worried about was that this tool looks like it's coming right down to the edge of the stock material. That's fine in a digital environment. When you get into the actual environment, the actual world, you might get a little bit of material actually left, like a really thin layer of like aluminum, which might also be dangerous. So what we're going to do is we're going to go make this go a little bit lower. And this is about how far the contour went in the last toolpath, or sorry, in the first setup. So if we see this, depending on how deep we went here, that determines how much material is left on the other side. So I think that we had a 0.02 below, kind of height to go below the contour. And if we had a 0.02 stock to leave, radial and axial stock to leave in setup 2, then it's going to be the same position. So I'm going to go a little bit lower here. So I'm going to go to adaptive 3 and edit it. And in the passes tab under axial stock to leave, I'm going to say 0 and click OK. What that's going to do is it's going to make the toolpath depth of this toolpath go all the way to the bottom of the model, but it's still going to be offset on the sides of the model. So I think it's going to be okay. Right click setups and simulate, and I'll go down to the bottom one here. And let's see. Yeah, that's good. You see it below, it's machining below, well below the bottom of the overhang. And we're machining from the side of the overhang. So we don't have to worry about entanglements or part ejections. Okay, that looks pretty good. So notice we still have a tiny little overhang here, but that's 20 thousandths of an inch, and it's not enough to cause any problem. So we're going to leave that. And we are going to exit the simulation. The next thing we're going to do is we're going to make a facing toolpath and bring the face mill out and get all the material off the back. So I'm going to go to 2D, face, For tool, click select, and we'll find that face mill from setup 1, tool number 1, and click select. Okay, geometry, default is fine for that. Heights, everything's okay. Passes, let's check multiple depths. Actually, let's not check multiple depths and let's see what happens. So go ahead and click OK. Just one pass. I'm going to right click on setups and say simulate. I'm going to go to the last toolpath, the facing toolpath, and it looks like here, you know, it looks okay. I'm not getting any collisions, right? But that, I know from experience, that depth of cut is way too much for this face mill into that piece of aluminum. You might get the tool pushing the aluminum out of the vise. You could get, you could break some of the teeth on the face mill. There's a lot of really bad things that could happen. So I'm gonna exit the simulation. Not every tool can do a full step down like that, and especially not the larger diameter tools, because the amount of the volume of material that you have to remove when you have a full step over like that, and you're cutting at such a large step down, is too much for the machine. You know, your spindle might just like burn out or just stop. So what we're going to do is we're going to kind of back this off a little bit, and the way we're going to do it is we're going to edit that facing operation. I'm going to go to passes, and I'm going to check multiple depths. Now maximum step down for this tool is 0.1, and that's something that we set, I think it's in the table, for the when we created this tool library in an earlier video. We don't always have to go to the maximum step down, especially because it's kind of like a small part. So I'm gonna back it off a little bit. I'm gonna say 0.05. You know, it's not gonna take a lot more time, and I think it's gonna be okay. So go ahead and click OK, and there it is. So let's give this a try. Let's go to right click on setups and simulate. I'm going to skip down to the facing operation, and let's see how we do. Okay, so a nice reasonable amount of material removal. You might be able to get away with a little bit more, but it really depends on your CNC machine and what it's kind of capable of doing. So yeah, there we go. Multiple step downs is a really common thing to do. It's a really common way to reduce the forces on the tool and on the machine, and to kind of manage the amount of material removal, the like volume of material removal. You can step it back by creating step downs of different sizes. Okay, last one. And there we go. Okay, so that is that's it. We have machined all the material all the way around our part, and yeah, that looks good. So we don't need to, let's see. We are not going to actually machine any other features on the bottom of this, so we're going to end it there. In the next project 3, we're actually going to like match features from the top that we machine on the top to the bottom, and that's going to require actually a third setup. We have to bring the probe out again a third time and make a new work coordinate system, and we're going to have to kind of redefine it so that we can align the machining from the previous setups with the machining that happens in the later setups. So it's a bit tricky. It's different most times. Sometimes it's kind of stays the same, but yeah, we'll do it a couple different ways throughout the course of this series. Okay, so that is it for Project 2 Setup 2. Go ahead and check out the next video. We're going to go over creating setup sheets, machining notes, and post-processing G-code for Project 2. So I will see you there.